So in this video, we're going to talk about directed line segments and partitioning a line segment. This is a topic typically introduced in a geometry class, probably around 9th grade. And it's a fairly easy question, although students might have trouble with it in the beginning because it looks like there's a lot going on here. However, once you memorize essentially 1.5 formulas, and you'll understand what I mean by saying 1.5 formulas, if you understand those 1.5 formulas, any question on partitioning, super simple, right? Easy points on any exam. Just as an example, in the New York State Regents test, that end of the year final that you take in geometry, this might come up once or twice, and that's an easy, 2 points, 4 points automatically. Okay, so let's talk about what partitioning a line segment is. Okay, so let's say you have a line segment MN, and I say that there's a point P such that MP and PN are divided into a ratio of A to B, where these are just some numbers, right? They could be 2 to 3, 8 to 5, something like that. Then I'm asked to find the coordinate points of P. Well, that's just a pretty simple formula right here. Now, here's the reason I said 1.5 formulas earlier. You have these two formulas to memorize, but if you look closely, they're the exact same thing, right? Coordinate points are made up of an x coordinate and a y coordinate, so you have to do the formula using the x coordinates, and then do the exact same formula using the y coordinates. Okay, now, the actual formula is x of p, so x coordinate of the partition is equal to x1 plus k, and I'll talk about that in a second, times x2 minus x1. Now, I didn't define what k is. K can be found using this real quick fraction. K is equal to a over a plus b, right? It's these two numbers in the ratio. It's basically the fraction version of the ratio. So if you could imagine this line segment, and let me use physical numbers. So let's say this is a 3 to 5 ratio. That would mean there are 3 equal parts on this side and 5 equal parts on this side. So in total, there are 8 parts that make up this line segment. Now, to travel from the beginning of the line segment to the partition point, how much of the way do you have to go in order to get there? Well, that's found by this fraction. So if it was 3 to 5, it would be 3/8 of the way down, right? A over a plus b. Right? So now let's look at some examples. I mentioned that this is a fairly easy topic, and it is. However, the way they could ask you the question changes. And we're going to go through a few different versions of how they could potentially ask you a partition question. So here is our first question. Okay, hopefully I printed that large enough for you guys to see. I'll read it out. Directed line segment DE has endpoints D that have the coordinates -4, -2, and E that have the coordinate points 1, 8. There's a point F that divides DE such that DF to FE, the ratio, is 2 to 3. What are the coordinate points of F? One thing I'm going to suggest doing to keep track of all these different things that are going on is just really draw a quick picture, right? It doesn't need to be super, great or anything. Just, okay, it said I have a line segment DE, right? D to E. And then I have some point F that divides this line segment right here. Okay, and I'll say that's F. And what it does is it cuts it into a 2 to 3 ratio. DF is 2, and FE is 3. So what are the coordinates of F? Now, the reason I want you to draw a picture is, like I said, I mentioned earlier that they could ask you the question in a few different ways, and keeping track of what is supposed to be x1, what is supposed to be x2, what is supposed to be k, what is y1, what is y2, that might get a bit confusing. Makes it so much easier when you use just a small little picture like this. Okay, so now we're able to use our formula. So we need to find the coordinate points of F. So let's start with the x value. the formula for finding the coordinate points of f, of the x value, right, is going to be x of the partition is equal to x1 plus k, x2 minus x1. Okay, now let's figure out what each of these parts are. So the coordinate point all the way to your left will always be x1 and y1. Then this middle thing is always going to be x sub p, y sub p, right? It's going to be these two values. And the coordinate point all the way to the right will be your x2, y2. So let's start filling this in. x1 is going to be -4. K is always a over a plus b. Now eventually you won't even need to write this out to the side. It's something you'll just be able to quickly do in your head. But the thing on the left is always your a term. The thing on the right is always your b term. So our fraction is 2 over 2 plus 3, which is 5. Easy enough, right? So plus 2 over 5, and then x2 minus x1. x2 is 1, right? That's the x coordinate of e. x1 is -4, minus -4. And this is something we can easily simplify, right? 1 minus -4 is basically 1 plus +4, so 5, right? So -4 plus 2 over 5 times 5. Then I get, okay, these cancel out, this 5 in the denominator and this 5 over here. And I'm left with -4 plus 2, which gets me the final answer of -2. Now we're basically halfway done with our with the problem, right? The only thing left is to get our y coordinate. Same formula, right? I'm basically just using this, but replacing all my x terms with y terms. So y sub p is equal to y1 plus k y2 minus y1. Okay. Now, what's nice is the k value, that fraction, that's going to be the same for both finding the x and finding the y. So that's great. We already have our k value. Our y1 is going to be the y coordinate of this first coordinate point. So that's going to be -2 plus k we already know to be 2 over 5. Then our y2 is the y coordinate of that second point, which is 8. And minus, well, what's y1? That's the y coordinate that we had earlier, of the first coordinate point of D. That's -2. So let's go about simplifying this, right? Almost done. So we have -2 plus 2 over 5 times, now what is 8 minus -2? Same thing as 8 plus +2, so 10. Simplifying this further, we get, what's 2 over 5 times 10? Well, I know this 5 and 10 will simplify, so this becomes 1, this becomes 2. And this eventually becomes -2 plus 4, right? 2 times 2. And that gets me a final answer on this side of +2. So what is my final answer? What are the coordinate points I found? That's going to be x comma y, right? -2, comma 2. Right? Easy as that. Now let's go to the next problem. As mentioned before, the trick to solving some of these is realizing that even though they might be stating the problem in a few different ways, it's basically the same formula that you're using. You just got to understand how to draw the picture and find what you're looking for. So what I suggest doing is pause the video and try it out for yourself. Okay, so here we have line segment PT has a point J that divides PT such that PJJT has a ratio of 2 to 1. Okay, so I'm going to start by just drawing that out. So here's my line PT. So this is P and this is T. I think that's a horror game, right? And then has a point J. somewhere there. That divides it into a ratio of 2 to 1. So I'm going to make that j. And it says 2 to 1. So the 2 is going to be the pj here, and the 1 will be the jt. Now, if you notice, I'm not even concerned with drawing this to scale. It definitely isn't, because this should be twice as long as this. We're really just doing this to keep track of, which coordinate point is what. Then what it does is it gives me the coordinate points of P, and it gives me the coordinate points of J. Then it asks me to find T. Now, see, that's a little bit different than what we just did, right? We have formulas to find the coordinate points of the partition. We don't, I didn't tell you how to find an endpoint, right? I didn't give you a formula for that. And that's kind of something where students have difficulty, because they're so used to mechanically just, use a formula, put in the numbers, and then get the answer without understanding what's really happening. So here's the difference between the last problem and this one. Here, I gave you these, I asked you to find this. In this situation, I gave you these two, I asked you to find this. In general, any sort of equation you might have, if you know everything except for one thing, you can basically find that missing thing. So in these partition problems, you're given 3 coordinates, 3 points. If you know 2 of the points, you can always find the third. So here's how that will look. So it's going to use the same formula, that partition formula. So for the x coordinate, it's this one. X partition equals x1 plus k x2 minus x1. So we go piece by piece. What is x of our partition? We actually know that they gave it to us. That's j. So j is 2, 5. So our x coordinate of our partition is 2. Now what's x1? x1 is the x coordinate of p, the thing all the way to our left in our little sketch. That is -2. All right? Now we need to find our k value. The k value is going to be a over a plus b, which is 2 over 2 plus 1, which is 3. So 2 over 3 is our k value. x2 is the x coordinate of our second point, which is t. Now we don't know what that is. So that's going to just remain x2. Right? And our x1 we know to be -2. Okay, so same equation, except the thing we're looking for is now different. So the unknown, the thing that is our variable, is just in a different spot. But ultimately, same problem. So let's go through this algebraically. How do I want to get x squared alone? Well, I'll start by adding 2 to both sides. And I'll get, so that's +2 plus 2. I'll get 4 is equal to 2 over 3. x2 minus -2, which is the same thing as plus +2. And now I'm going to multiply by the reciprocal of this fraction to get it to the other side. Okay, so I'm going to end up with multiplying by 3 over 2 here. That cancels. And I multiply by 3 over 2 on this side. And I get 6, right? 3 times 4 is 12. 12 divided by 2 is 6. So 6 equals x2 plus 2. After subtracting 2 to both sides, what I'm left with is 4 equals x2. Okay, now that I've done it for the x, should be super easy to do it for the y value. Right, same equation. Y of my partition equals y1 plus k times y2 minus y1. The hardest part is really setting up the equation. What is the y of my partition? Well, my partition is j. That y is 5. What is my y1? That's p, so that's going to be 1. What is k? We found that out earlier. 2 over 5. What is y2? That's actually what we're looking for. We don't know. So I'm going to leave that as y2. What is y1? Well, that's 1. We've actually used it earlier in the equation. And this is now something we solve for, right? I'll subtract 1 to both sides. I'll get 4 is equal to 2 over 5 times y minus 1. And then I'll multiply to both sides. 5 over 2. That cancels. And I multiply to both sides. I used 2 over 5. I should have used 2 over 3. Luckily, that doesn't change it. I used 2 over 3 up here, so that's correct. 2 over 5 was our last one, I think, so that's my bad. This should be 3. And this should be 3. So I'm multiplying 3 over 2 to both sides. And then 4 times 3 over 2 is 6. And I got 6 again. So I'm going to write it over here to the side where I have room. 6 is equal to y2 minus 1. Then I simply add the 1 to both sides. And I'm left with y2 is equal to 7. Okay? So what is the coordinate point of t? Well, point t would be the coordinate points. My x coordinate is 4, and my y coordinate is 7. Right? Simple as that. So this is just kind of a demonstration. I don't really want to hammer this point home. If you just draw a little picture, use these equations, you'll be able to plug in super easily. Let's go to a different looking example. So, like I said in the last problem, I suggest you pause the video and try this out for yourself. It looks a little different, but same concept. So here it asks us to find the coordinates of P that is 3/4 of the way along a directed line segment from D to C. Now, this definitely looks quite a bit different than our previous two. Mostly because it doesn't give us a ratio. It gives us a fraction. And you know what? I like that better. Because this fraction it gives us when it says, oh, you're 3/4 of the way down a directed line segment, you're this fraction of a way down, that's our K value. We don't even need to compute that. We know 3 over 4 is K. Now, how do we know what our x1, y1 is and where x2, y2 is, right? And by that I mean, how do we know, like they give us two coordinate points, DC, but how do we know whether it's DC, right, or CD? That's kind of tricky because depending on which one it is, our answer is going to turn out different. The way you figure that out is the wording. They say a directed line segment from D to C. That means you're traveling from D, starting there, and you're moving to C, ending there. All right? You're going from left to right. So D is going to be your x1 from D, x1, y1. And C is going to be your x2, y2 to C. All right? Hopefully that clears that up because I find that is where people will make the most mistakes on this. And point P is somewhere here. Now, I don't even care about the ratio. I already have the fraction. So I go straight to the formula. X of the partition is equal to x1 plus k, x2 minus x1. What is my x of the partition? That's actually what I'm looking for. So that's going to stay as xp. What is my x1? Well, that's the x coordinate of D, so 6 plus k, which is 3 over 4. That's great. Times x2, which, what is that? Negative 3. Minus 6, which is x1. Now, computing all this, we get, 6 plus 3 over 4 times, what is this, negative 9. And this is going to end up being a fraction as a coordinate point, which is totally fine. Coordinate points can have fractions in them. So 3 times 9 gets us 27, and I don't believe that simplifies, right? So we have 6 plus negative 27 over 4. Now, how do I get this into like terms? I can slightly adjust this. So this should be something I find people have trouble with this, even when they're in high school, and they should already know this. But just adding and subtracting fractions, right? I need this to match this denominator when I'm adding them. So I need to do now 24 over 4 plus negative 27 over 4. And what I end up with is a negative answer, negative 3 over 4. Right? And that is my x coordinate for the partition. And I'm going to need a separate piece of paper for doing the y. My bad there. So y of the partition, I'm just going to go through this pretty quick, because at this point, this might be getting a bit boring. And that's a good thing. I say it a lot, but boring means you're getting used to it. You're getting used to the actual formula, used to just how something like this would look. So x to the partition is what we're looking for. Y1 is going to be negative 5. K is going to be 3 over 4. What is y2 is going to be 4. And what is y1? That's going to be minus a negative 5. Okay? And we just do this algebra out. So we have negative 5 plus 3 over 4 times 9. That's what 4 looks like. Multiplying that out, we have negative 5 plus 27 over 4. And by adding those together, the negative 5 becomes negative 20 over 4 plus 27 over 4. We get a final answer for our y coordinate of positive 7 over 4. So our final coordinate points, they equal negative 3 over 4, comma, 7 over 4. And that's point of the partition. Now we're going to do one final example. Here, we're asked to find the coordinates of point P that lie 3 halves of the way on a directed line segment AB, and they give us the coordinates of A and B. Now, I know you're sick and tired of me saying it, but let's draw a picture. Okay? So we go from A to B, and here they don't say A to B or anything like that. They actually give us the line segment in the line segment form. Right? So we know that if it's line segment AB, it's actually drawn that way. If it said BA, B would be here, A would be here. And they give us a fraction, so great. I don't have to even do any work to get K. That's it, that's K. And we need to find a partition point P. So real quick, let's do it. So x to the partition point is equal to x1 plus k, x2 minus x1, right? You should be doing this faster than me at this point. You don't even have to think about it, hopefully. So what is x1? That's negative 2. What is k? That's 3 over 2. And what is x2? That's 4. And then minus negative 2. Simplifying all this down, negative 2 plus 3 over 2 times 6, and that gets us 3 over 2, so this simplifies just being 3 times 3, 9, right? And then 9 plus negative 2 gets us positive 7 as our final x coordinate. Same equation for y. All right, so let's substitute our numbers. So y1 is 5. K is 3 over 2. What is x2? Or I wrote x2. I make the mistake a lot, but it's important to catch yourself. So what was I doing? Yeah, so y1 was 5. Y2 is 9. And minus 5. So this is going to become 4, right? 9 minus 5 is 4. 4 times 3 over 2 is 6, plus 5 is 11. One more. So our final coordinate point for this problem is the partition coordinate point is 7, 11. That was an accident. So just to quickly go over, partition problems, super easy, okay? Really memorize this one formula. You're going to do it for the x-coordinate. You're going to do it for the y-coordinate. And then from there, when you're first given a problem that talks about, hey, you have a directed line segment, or something splits it up into a ratio, or anything that sounds like a partition of a line segment problem, draw a picture, then put it into your equation. Okay? If there are any questions, anything you want me to clear up, throw it down in the comments below. But other than that, good luck, guys.